y equals, correct? Now, some people say this is with my x. If the x doesn't have a bracket, where is the bracket? Only around the x. Gotta need a marker. So it's only around the x. So this is a vertical. Now watch out. With trig, they use different words for the vertical translation and the horizontal one. So they don't say vertical translation. I want you to write that so you put a line through it and change the word. It's only in trig. I want you to draw a line through it so that you catch yourself. So you're going to have vertical translation on your paper. For trig, it is vertical displacement. I specifically want you to cross out that translation so you see it's different, but only for trig. Talk to the higher ups because I don't know why. They just change words. So it's vertical displacement, 3 units up. So instead of vertical translation, it's vertical displacement. And instead of horizontal translation, it's horizontal phase shift. You're welcome. All right. The mapping for this one would be x, y becomes what? How do I move 3 up? I take the y and I do what to it? Add 3. Yeah? Okay. Is this one vertical or horizontal? Vertical. What about this one? Vertical and y. Stretch. Vertical. Okay, flip over. What's this one? Horizontal and vertical. This, what's your x-axis in? It's your c value that tells you. This is in radians. There is no c value, I have to tell you. What about this one? What's it in? Degrees. There's also a catch for this one. What's the problem? There's not a 1 in front of the x. So I have to go y equals sine 1/2, and the x being a theta. Theta minus, what happens when you take a fraction out? That's between 0 and 1. What happens to your c value? It gets bigger, right? So what's 15 divided by 1/2? The same as 15 times 2, so it's 30. Remember, you double check yourself by inputting it back in. If I put this back in, half of theta is half theta, half of 30 is 15. If I had put 7.5, half of 7.5 is even smaller, right? When you distribute that GCF back in, you should get back what you had, right? So that's why when you take that half out, you're dividing by 1/2, which is multiplying by 2 because GCF's division. This one has it out. This one is in radians. I want the translations and mapping for all of them. Okay, so this one is a vertical displacement. Two units down. And words and mapping are the same. Actually, y is always the same. So it's going to be to move it 2 down. I have to take all my y values and subtract 2 from them. That's how I move them down. Okay, this one is a vertical stretch. By a factor of 3 about the x-axis. So it's about the opposite. And a vertical displacement two units up. So it's going to be x, y becomes, x stays the same because nothing happened to the x. It's just sitting there, correct? And then my y is 3y plus 2. 4 has a vertical stretch, a reflection, and a translation, but it affects all the y's. So we get a vertical stretch by a factor of 2 about the y-axis. And by the y-axis, I mean the x-axis. And then a reflection in the x-axis. And a vertical displacement 3 units down. So we get x, y becomes x, comma, negative 2y minus 3. Okay, we're going to finish the rest in a second. I just want to talk about all of these. Did any of these affect x's? Nothing affected x's, correct? So let's talk about this one. It moved 3 up. Remember our amplitude. What is our amplitude equivalent to? Amplitude is the same as the vertical stretch. Remember? And why is that? Because it's from negative 1 to 1, and the only thing that changes negative 1 to 1 is a vertical stretch, a multiplication of a value. Correct? I multiply by 3, now it's going to be negative 3 to 3. I can move it up or down, and it's not going to change my amplitude, because amplitude is half the vertical displacement, technically half of the distance, vertical distance. My brain stopped. Okay, not displacement. All right, so amplitude is based off the vertical stretch. Will the amplitude change in this one? There is no vertical stretch, so that doesn't change. What about the range? Will the range change if I take the entire graph and I move it up 3? Yeah. Will the period change? Period's affected by the horizontal stretch, correct? Is there a horizontal stretch? No. No bueno. Domain doesn't ever change. It's XCR unless I restrict it, correct? Are your x-intercepts going to change by taking the entire graph? I take an entire graph and I move it 3 up. Is it going to change the x-intercepts? Is it going to change the y? Yes. All right. Let's talk about a coast graph. Coast graph starts at 0, 1, yes, and then it goes like this. Maximum 0, 1 on the y-axis, right? So this one has a vertical displacement 2 down. Is the amplitude going to change if I take the entire graph and shove it 2 down? No. Is the range going to change if I take the entire graph and I shove it down? Is the period going to change? Horizontal stretch affects that. This isn't affected. What about if I take the entire graph and I shove it 2 down? X and y intercepts going to change? Yes. 3 has a vertical stretch. Will my amplitude change? My amplitude is normally 1. It's now going to be 3. So my amplitude is going to change. Is my range going to change? If my amplitude changes, my range changes, right? It's going to be from negative 3 to 3, and then I have to move it up 2. It's going to change it. So my range is going to change. Period and domain? No. What about an x and y intercepts? Yeah. If I only, if I only had a vertical stretch, would my x-intercepts change? No, because my x-intercepts have y's of 0, and vertical stretch is multiplied. 0 times anything stays 0, right? So it's actually the vertical translation that's moving the x-intercepts here, not that vertical stretch. 4, same thing's going to happen. My amplitude is going to be what this time? 2, not negative 2, 2, because amplitude is the absolute value, right? It's the vertical stretch. Okay? The range is going to change. The period and domain are not, and so are these two. Okay, let's flip. Now I'm going to have stuff happening to my x's and y's, right? So this has a vertical stretch. As long as the y equals y is always the same. Vertical stretch by a factor of 1/3 about the x-axis. I don't have a horizontal stretch. I do have a reflection in the x-axis. I have a vertical displacement 2 units up. and I have a horizontal phase shift. Pi over 2 radians right. Because now we know the units. It's either radians or degrees. Okay. What's my amplitude for this one? 1/3. So did it change? It's normally 1. Yeah. Is the range going to change? Yes, the moment your amplitude changes, your range is going to change. Not only is your range going to change, the inequality signs are going to change. You're going to multiply by 1/3 and then add 2. So your range is for sure going to change. Is the period going to change? No, because the horizontal stretch is what changes your period. We don't have one. Domain doesn't change. X and Y intercepts, are they going to change? Yeah, I'm moving it pi over 2 to the right. I'm also moving it 2 up. So both of these are changing. This one I have in y equals now, and I have a 1 in front of my theta, so I can start. I have a horizontal stretch. I'm going from equation to words, so what's going to happen? I'm going over that double-headed arrow. The x's would be crazy. They're going to flip. So the horizontal stretch by a factor of 2 about the y-axis. And a horizontal phase shift. degrees right. Only x stuff happening now, right? Will my amplitude change? My amplitude's 1. It's still 1 because my vertical stretch is 1, so it doesn't change. If my amplitude doesn't change and it doesn't move up or down, is my range going to change? It's going to be from -1 to 1. That's not good. Period, did it change? It's going to do what now? It's double. So it's going to be 720 degrees. Because C is in degrees, your period would be in degrees. Domain just stays the same. X-intercepts, I'm going to multiply them by 2 and then move them 30 to the right. Are my x-intercepts going to change? Yep. Is my y-intercept going to change? I'm going to multiply my 0 by 1/2, or by 2, sorry, so that doesn't change, but then I'm moving it 30 right. So is my y-intercept going to change? Yeah, you're taking your entire graph and shifting it 30 to the right. So the moment you have a horizontal or vertical translation, you're changing. So it's phase shifts or displacements. Okay, this one has a horizontal stretch. By a factor of 1/3 about the y-axis. And a horizontal phase shift. I've been forgetting the mapping. Pi over 2 radians, right. So the mapping is going to be x, y becomes, remember words to mapping in a heart, same numbers, right? So it's going to be 1/3 x, comma, what I should have been doing this whole time is, what I should have been doing. So we don't have an x, we have a theta. And this one. And then, because it's still the same thing's happening, your amplitude range doesn't change, period does, domain doesn't change. Okay, let's talk about range of your basic functions. So, you have a midline. Midline is actually the d value of the equation. The midline is the line that cuts the graph in half vertically. Okay? So on your basic sine graph, when we have y equals sine theta or sine x, let's say, your d value is 0. Just sits at the back, yes? Okay? This is your, we're going to talk about it in the next lesson. This is your your midline. So it's the line that cuts the graph in half. So this graph is actually cut in half at y equals 0. Remember, horizontal lines are y equals lines and vertical lines are x equals lines because it's cut the x-axis. Okay, what's my amplitude? 1 in this case. So I would go up 1. And I'd max at what? I'd max at 1, right? And then I would go down 1 because my amplitude is 1. Remember, it's half the vertical distance. So my min would be at what? -1, right? So technically, if I know what my midline is, and I go up that amount to my amplitude and down that amount to my minimum amplitude, I get my min and my max. Now, what you can do is you can damp. To get the max, you're going to do d plus amp. And to get your min, you're going to go d minus amp. Would it work if you went amp first? If you went amplitude first, it wouldn't make sense because you need to take that midline and add the amplitude. So, how we get the range is we need the max and the min, correct? Okay. So what would the max be of this one? What is my D, my midline? And I'll answer it once. My midline, my D. Let's go through this. Okay, so it would be y equals 1 sine 1x plus 0 plus 3. If we did this as A, B, C, Ds, yes? So this would be my A, this would be my B, C if it doesn't exist is 0, this would be my D. D. Cool. So that's the midline. The middle of this graph is at y equals 3, so let's envision it. Okay, guys. I want you to understand, not memorize, right? You can remember down if you want to, but we're going to know why. So y equals 3 is my midline, correct? Because d is 3. What's my amplitude? My amplitude is 1. So if I add 1 to that, what's it maxing out at? And then if I min out, I go down by 1. My min is what? My min is 2. Who's making wind noises? Holy. 3 plus 1 is 4. Minimum is 3 minus 1, which is 2. So my range is from 2 to 4. Okay, we'll do one more together. What is my midline on this one? My midline is y equals -2. True. So we go like this, we go like this, we go like this. Y equals -2 is my midline. Yeah? Okay, what's my amplitude? What's my amplitude? 1. So I'm going to go up 1. So what's my max at? And I'm going to go down 1. What's my min at? So we can draw it out if we want, or we can go, the maximum is D, -2 plus amp, which is -1, and my minimum is D minus amp, which is -3. And if I do it in set notation, it's going to be -3 is less than or equal to y, less than or equal to -1. Okay, go do the rest. Go, quick. So the range of this one, our max is going to be our midline, which is 2, plus our amplitude, which is 3, and we get 5. Our min is going to be our midline, which is y equals 2, and then we subtract 3 from it, so it's negative 1. So it's going to be negative 1 to 5. Interval. 4, our maximum is our d, so our midline's now at negative 3, and we're going to go up 2 and down 2. So it's going to be negative 3 plus 2. And then our minimum is going to be negative 3 minus 2. Just packing up when it's 9:45 and there's still 15 minutes left. No big deal. NBD. Not paid enough. Negative 1. Negative 5, negative 1. All right. This one is going to be 2 plus 1/3, 2 minus 1/3. So we get 6 over 3 plus 1/3, which is 7 over 3. And here we're going to get 6 over 3 minus 1/3. So we're going to get 5/3, and we're going to be quiet. We're going to try that out. Skill. Okay, table. Don't make me threaten. I will do it again. And then I will follow through. All right. This one, nothing. Our midline is 0. Our max, or this amplitude is 1. So what is our range? Negative 1 to 1. All right. Okay, stop. Read the room. All right. The period of the graph, if we go back here, number 1, the period, has there been a horizontal stretch? No, so you give 360 or 2 pi, and the reason why is I didn't tell you if it was radians or degrees because your c value is 0. This one has no horizontal stretch, so it's 360 or 2 pi again. This one has no horizontal stretch and no horizontal phase shift, so 360 or 2 pi, I would have to tell you if it's radians or degrees. This one, once again, same thing, 360 or 2 pi. The next one is in radians. So what's it going to be? 2 pi, because there is no horizontal stretch. The next one's in degrees. We're stretching it by 2. So it's going to be 360 times what? Which is 720 degrees. And then the last one is in radians, and we have a stretch by 1/3. So it's going to be 2 pi times 1/3, which is 2 pi over 3. Then go ahead 2 pages. Okay, what are these? Determine the equation if I give you words. This one's the graph of this transform, determine the transformed equation. Go. 3 and 4. Wrong. So we need amplitude. True. Amplitude is our A, right? The absolute value of A. Cool. We have a horizontal phase shift pi over 3 to the left, and we're doing sine something. X plus pi over 3. And a vertical displacement 1 down. And then I get a whole bunch of people putting pi here. This is the period. This is the period. Are they the same? No. No, they're not. No, they aren't. Okay? So we can either do B equals 2 pi over P, or B equals 360 degrees over P. So this one is pi, correct? That's the P. P is pi. I want B. So B equals 2 pi over pi, which is 2. Does that make sense? I have a horizontal stretch by 1/2. 2 pi times a half is pi. It makes sense that period is pi if b is 2, because that's a half. Okay, this one would be y equals 1/4 sine something. Phase shift to the left pi, so I go x plus pi. 2 up. This is the p. The p is 6 pi. So it actually tripled. So this will be a third. If you can't envision that, use your formula. b equals 2 pi over 6 pi. Yield pi cancel, and I'm left with a third. Right? Just use the formula. This one, we have y equals 4 sine something, x minus 60 degrees, minus 3. I need this something. This is 540, so I'm not going to go 2 pi divided by p. I'm going to go 360 degrees divided by 540, because you get the degrees cancel. So b equals 360 degrees divided by 540 degrees equals 2/3. Yeah. And 2/3 makes sense. This makes sense because it would be 3/2, so it'll get bigger. This one is nicer than that one. Why? Just transformation. It's nicer if you're good at transformation. It's worse if you're not. So it'd be y equals 1/3 cos, horizontal stretch by 2, so a half. Horizontal phase shift 30 right, x minus 30 degrees. Vertical displacement 5 down. This one would be vertical stretch by factor of 4. Cos horizontal stretch by 1/4, so I get 4. Horizontal phase shift, x plus pi over 2. Make it left, then plus 3. Hold up, holla. That's your homework. Make sure you do it.